Hi, so this is the notes for solving polynomial inequalities. So in the past we have graphed polynomials, and today we're going to talk about inequalities, right? We've been dealing with equations so far. So inequalities, we're going to use, less than, greater than, equal to. So it says the graph of the function is pictured to the right. Use the factors to find the zeros of the function. We're actually going to use the graph, right, instead of the factors. So we're going to use the graph. We see the zeros here at -3, at 0, and at 2. So we know this is at least x to the third. We see x to the third here because there are 3 solutions there. So if we were just solving the equation, if it was set equal to 0, those would be our answers. Today we're going to think about inequalities, so it's going to be a section of the graph. So let's review interval notation to start. Using the graph, same graph, identify the values of x for which each of the following equations or inequalities is true. So we just talked about those equal to ones, right? 3, 0, and 2. I'm going to write them like this, 3, 0, and 2. Remember, squiggly brackets just mean like individual values. So we're not talking about an interval there. Then for this next one, it says f of x is greater than 0. So if you remember from interval notation, we're talking about where it's greater than the x-axis. So that'd be this section here. That means, technically means like above the x-axis. And we would say that that is from -3 to 0. I'm going to put those in parentheses since it is not or equal to. And then again from 2 to infinity. Right, from 2 to infinity. So that is that yellow section of the graph. If we were thinking about what's greater than or equal to 0, right, greater than or equal to, we're going to have the exact same thing, but in this case we're going to use -3 to 0 in brackets with that 2 in a bracket, infinity always having parentheses, right? So it's the same section of the graph. We're just saying that like now those points are included at -3, 0, and 2. For the number 3 and 5, where it says f of x is less than 0, now we're looking below the x-axis, right? Now we're looking at this section here and that section there. So we would have from negative infinity, right? Negative infinity over here, all the way to -3 in parentheses, and from 0 to 2. Right? Same thing for my greater or my less than or equal to, right? Except we're going to use those brackets. Except in this place, we're going to have negative infinity. Infinity always has parentheses, -3, bracket, 0, 2. Just like that. So these are sort of the intervals where these things are true. We're going to use parentheses when it's not equal to, and brackets when it is equal to. You'll see those points that we had, right? The point of 3, 0, and 2, 3, 0, and 2. Those are the only really numbers we use here. Oh, let's make that a negative. -3, -3, 0, and 2. -3, 0, and 2. These are sort of like our really important points, and we're going to see them throughout in every single option, -3, 0, and 2. So we're going to see all of those answers have those numbers in it. So that's a quick review on interval notation. We're going to use it to solve our polynomial inequalities today. So first step's always the same, completely factor it. So we see the same problem here. I'm going to go ahead and divide by x. Right, so we have x squared plus x minus 6, still greater than or equal to 0. I have x, this is going to split into +3 and -2, right, from doing my x, -6 and 1, 3 and 2, we want our -2 to be there. So this would be 0, -3, and 2 as our critical points. So we factored it, we found the values, now we're going to draw the graph. So I'm going to go ahead and draw my graph here. I have 0, -3, and 2. I know it's positive, so I'm going to be headed up at the end. And these are all single roots, so I'm headed through like that. I don't really need to draw like a really fancy graph. I don't need like a fancy axis or anything. But then I do want to check out, like, is it greater than or equal to, or less than or equal to? In this case, it's greater than or equal to. So I'm looking for places above the x-axis, that highlighted place there in blue. So I'm going to go from -3. It is or equal to, so I'm using brackets until 0. And then from 2 to infinity. So this, what I've just written here, is the interval where the polynomial is greater than 0. So this is the solution to our problem. Okay. It's addressing where the line is above the x-axis. So that is our problem here. That is sort of the full-length process for the problem that we were addressing up here. So let's look at this one really fast. Example B. It says completely factor polynomial. It's already factored. I'm going to find my zeros. I have 0 here, -2, and this is 2, but it has a multiplicity of 2. This is a double root. So when I draw my graph, I'm going to have 0, I'm going to have -2, I'll have +2. This is a double root here. It is negative at the beginning, so I know that it's going down at the end. So down, and it is bouncing, going through 0, and then back through -2. So the graph looks like this. And the graph is asking, where is it less than 0? It's less than 0 for most of the graph here. We see this section here, we see this section here, and we see this section here. The reason I have to call this 2 separate sections, like the green section here and this blue section there, is because at 2 it is or equal to. In this problem it's not or equal to, so we have to pick up our pencil there. So from -infinity to -2, from 0 to 2, and from 2 to infinity. This is where a graph is less than 0. So this whole thing would be our solution to this problem. Cool. This last question is a thinker. How would your solution to the above inequality be different had the original equation been this same equation but with a greater than symbol instead of a less than? And I'd say it would be the part of the graph that's not here, it would be above the x-axis. It would be above the x-axis, so it would be that -2 to 0 section. Right? -2 to 0. Cool. This is solving polynomial inequalities. Your homework will do a lot of the same things, so you've got those sections there and inequalities to check it out. Thanks, y'all.